The flagship was dying, and everyone who mattered was watching. Kessa Road heard the alarms from 3 decks away, a deep structural groan that pulsed through the hull plating of drydock Thyarren like a heartbeat losing rhythm. She was on her knees beneath a coolant junction in Bay 14, welding a patch onto a cracked manifold pipe that had been leaking thermogel for 2 shifts because nobody had filed the repair order, and nobody was going to file the repair order because Bay 14 serviced freight haulers, and freight haulers did not generate the kind of paperwork that moved up the chain. She killed the arc on her torch, flipped her visor up, and listened. The groan came again, deeper. The overhead lights in the bay flickered once, and through the transparent wall of the service corridor she saw a squad of Thyarren naval engineers sprinting toward the main concourse, their silver-white uniforms blurring against the polished deck plating. One of them was shouting into a communicator. She caught fragments: structural cascade, primary keel beam, containment risk. That was the Ascendancy-class dreadnought in Bay 1. The Welder, flagship of the Thyarren 7th Fleet, the single most expensive piece of military engineering in 3 star systems, currently sitting in the drydock's main cradle for what was supposed to be a routine refit of its forward sensor array. Kessa had seen it from the observation gallery 2 days ago when she walked past on her way to swap a fused relay in Bay 11. A 1.5 kilometers of pale silver hull, bristling with weapon emplacements and shielded sensor domes, floating in the drydock's magnetic cradle like a cathedral suspended in air. She picked up her torch, clipped it to her belt, grabbed her tool bag from beneath the junction, and walked toward the noise. She was not supposed to be anywhere near Bay 1. Bay 1 was restricted to Class 3 engineers and above, which meant Thyarren fleet personnel with at least a decade of service and formal certification in capital ship systems. Kessa was a Class 8 contractor, the lowest rating the drydock issued, a designation that meant she was qualified to weld pipes, swap relays, patch hull microfractures on civilian vessels, and otherwise perform the kind of work that the Thyarren Engineering Corps considered beneath their training. She had been at drydock Thyarren for 9 months. Before that, she had spent 4 years at a fuel depot in the Varathi Belt, and before that, 6 years at a commercial shipyard on the outer circuit, and before that, 11 years on Earth, working the floor at Rennick-Hartley Heavy Industries in the kind of facility where you learn to weld by welding, and you learned hull stress by watching hull stress, and you learned what a structural failure sounded like because the old hands made sure you heard one before you ever had to see one. She was 38 years old. She had grease under her nails that no solvent had been able to reach in roughly a decade, and she knew what a keel beam sounded like when it was about to let go. The main concourse was chaos. Kessa pressed against the wall and watched the traffic flow. Thyarren engineers, dozens of them, moving in coordinated clusters toward Bay 1's primary entrance. Officers in pale blue command uniforms directing the flow. Security cordons going up at every junction. Through the transparent walls of the concourse she could see Bay 1 itself, vast as a cathedral, the Welder floating in its magnetic cradle with emergency lighting strobing across its hull in amber pulses. And she could hear it, not the alarms. Beneath the alarms, beneath the shouting and the boot strikes on the deck plating, she could hear the ship itself. A low, sustained vibration that was not quite a sound and not quite a tremor, something between a groan and a hum, resonating through the drydock's structural frame and into her boots and up through her knees. She had felt that vibration before. Once, 12 years ago, when a cargo freighter's spine had buckled in the yard at Rennick-Hartley, and the entire starboard frame had twisted 9 degrees before the emergency clamps caught it. She had been 19 meters from the hull when it happened, close enough to hear the metal scream, close enough to feel the frequency shift from vibration to fracture in the half-second before the beam gave way. This was the same frequency. The Welder's primary keel beam was not stressed, it was pre-fracture. She moved. The security cordon at the Bay 1 junction, was two Thyarren guards in formal armor, their pale lavender faces expressionless beneath crested helmets. They looked at her coveralls, her tool bag, her welding torch, her human face, and their expressions did not change because their expressions were already at the precise setting that meant this person is beneath the threshold of notice. Bay 1 is restricted, the taller guard said without looking directly at her. Class 3 and above. Your keel beam is going to fracture in about 40 minutes, Kessa said. The guard blinked. Thyarren blinks were slow, deliberate things, almost theatrical. His luminous silver-green eyes tracked down to her contractor badge, where the number 8 was printed in Thyarren script beside the word human. The engineering teams are addressing the situation, he said. Kessa nodded. She could have argued. She could have told them that the sound she was hearing through the deck plating was not the sound of a ship under stress. It was the sound of a ship about to die, and that she knew the difference because she had spent 20 years in places where nobody else could tell the difference, and the consequence of nobody knowing was that ships died and people died with them. But she had been a Class 8 contractor for long enough to know that arguing with a security cordon was like welding against the grain. It did not work. It wasted energy, and it left you worse off than when you started. She walked back down the concourse. Around her, the drydock was waking up to the crisis. More engineers streamed past, their boots clicking in coordinated rhythm against the polished deck plating. An automated announcement in Thyarren, calm and precise, informed all non-essential personnel to clear the Bay 1 concourse. A medical team jogged past with emergency kits. Through the transparent walls she could see the observation gallery above Bay 1 filling with administrative staff and civilian workers who had been evacuated from the surrounding sections, their faces pressed against the glass, watching the flagship in its cradle with the fascinated horror of people who understood enough to know something terrible was happening, and not enough to know what it was. Kessa knew what it was. She had been 18 the first time she heard a structural member reach pre-fracture frequency. Hal Rennick had grabbed her by the shoulder and walked her to the base of a loading crane in the east yard and told her to press her palm against the mounting bracket and listen. Just listen. She had felt the vibration through her hand, a tremor so fine it was almost a temperature rather than a motion, and Hal had said, "That is what dying sounds like when nobody has taught you to hear it. That bracket will fail in 72 hours. Nobody on this floor knows it except you and me. Remember this frequency." She had remembered it. She had heard it 4 times since, on 4 different structures, in 4 different facilities. Each time she had found the crack before it became a fracture, fixed it before it became a failure, and done it so quietly that nobody above her classification had ever known there was a problem. That was the job. Not the fixing, exactly. The noticing. The fixing was just what you did after you noticed. Anyone could fix something once they knew it was broken. The skill was knowing it was breaking before it broke. She reached the maintenance access hatch 40 meters down the concourse. It was not guarded because maintenance access hatches were not the kind of thing that warranted guarding. She pulled it open with the override code she had memorized during her first week, and dropped into the service crawlway beneath the main deck. The crawlway ran the full length of the drydock. It was 1.5 meters wide, lit by emergency strips, and it smelled like thermogel and old insulation. Kessa had spent more time in these crawlways than in any other part of the station. They were where the real infrastructure lived, the pipes and conduits and junction boxes that kept the drydock running while the polished concourses above stayed polished. She moved through them the way she moved through most of the station, quickly, quietly, and without the expectation that anyone would notice. 30 meters in, she stopped. A power conduit running along the ceiling of the crawlway had developed a hot spot. She could smell it before she saw it, the faint, acrid scent of insulation reaching thermal limits. The conduit fed the emergency lighting system for bays 3 through 6, and the hot spot meant a splice joint was degrading, probably corroded from the thermogel vapor that drifted through the crawlways and settled on everything. It was not urgent. It would not cause a problem today, or tomorrow, or next week. But in a month, maybe 2, the splice would fail, and the emergency lighting in 4 bays would go dark the next time someone needed it. She pulled a wrapping of heat-resistant tape from her tool bag, cleaned the splice joint with a cloth, reseated the 2 leads that had shifted from thermal expansion, and wrapped the joint tight. 45 seconds. Nobody would know she had done it. Nobody would know it had needed doing. That was fine. That was the job. She kept moving. At the junction where the crawlway branched toward the primary bays, she passed a junction box that she had repaired 3 weeks ago. The relay inside had been arcing intermittently, sending power surges through the atmospheric monitoring system in Bay 7. She had filed a report. The report had gone into the drydock's maintenance queue, which was managed by an automated prioritization system that ranked tasks by the classification of the bay they affected. Bay 7 was a Class 6 bay, which meant it serviced corvettes and patrol craft. The atmospheric monitoring system in a Class 6 bay was not a priority item. The report was still in the queue. Kessa had bypassed the queue and fixed the relay herself, because the atmospheric monitoring system in a Class 6 bay was the thing that told the crew whether they were breathing poison, and that seemed like the kind of thing that should work. The relay was holding. She checked it with her fingertip as she passed, feeling for heat, for vibration, for any sign that the fix was degrading. Cool, stable. She moved on. Bay 1's service level was directly beneath the main cradle. She came up through a floor hatch into a cavernous space filled with magnetic emitter arrays, power conduits thick as her torso, and the massive structural pylons that supported the cradle. The Thyarren hung above her, close enough that she could see the individual hull plates, each one 8 meters across and seamlessly joined. The emergency lighting painted everything amber and shadow. And there, 60 meters ahead, she saw the problem. The forward cradle pylon, the one that anchored the magnetic array supporting the Thyarren's bow section, had developed a stress fracture along its base mounting plate. The fracture was not large. From a distance, it would look like a hairline, a thin dark line running diagonally across the mounting plate where the pylon met the drydock's structural frame. But Kessa could see the micro-deformation around it, the way the metal had begun to bow outward along the fracture line, millimeter by millimeter, as the weight of 47 million metric tons of dreadnought pressed down through the magnetic array and into the pylon and into the plate, and into that thin dark line. If the plate failed, the pylon would shift. If the pylon shifted, the magnetic array would destabilize. If the array destabilized, the Thyarren's bow would drop, and a 1.5 long warship settling even 3 degrees out of alignment in a drydock cradle would generate enough torque to shear every remaining pylon in sequence. The ship would fall, not into space because the drydock was pressurized, into the bay floor. 1,200 crew still aboard for the refit. She knelt beside the pylon base and pressed her palm flat against the mounting plate. The metal was warm, not from ambient temperature but from molecular stress, the friction of crystalline structures being pulled apart under load. She could feel the vibration through her palm, a high-frequency tremor that had no business being in a structural member this thick. She traced the fracture line with her fingertip. It ran 17 centimeters, northeast to southwest, and the micro-crack network radiating from it spread another 8 centimeters on either side. She had seen this before, not on this alloy, not at this scale, but the pattern was the same. Fatigue fracture from cyclic loading, probably initiated months ago by a microvoid in the casting, propagated slowly under the repeated stress of docking and undocking cycles, until it reached the threshold where propagation became exponential. Someone should have caught it during a routine inspection. Someone would have caught it if anyone had been inspecting the mounting plates by hand, instead of relying on automated sensors that were calibrated for catastrophic failure, not the slow creep that preceded it. She heard voices above her. Through the grated deck overhead, she could see the main bay level, where a cluster of Thyarren engineers had gathered around a diagnostic terminal, their voices carried down clearly through the grating. The stress analysis confirms progressive deformation in the forward mounting plate. Rate of propagation is accelerating. What is your recommendation? We need to evacuate the vessel, decompress the bay, and initiate an emergency undocking sequence. If we can get the Welder out of the cradle before the pylon fails, we can prevent a cascading collapse. How long for the undocking sequence? Standard emergency protocol is 90 minutes. The reactor needs to be brought to operational status, the docking clamps released in sequence, the maneuvering thrusters calibrated for the bay dimensions. We may not have 90 minutes. That was a new voice, deeper, with a harmonic quality that marked it as someone of rank. Kessa shifted to get a better angle through the grating and saw a Thyarren woman standing at the edge of the engineering cluster, her posture so straight it looked architectural. She wore a deep indigo uniform with silver thread at the collar, and her pale blue-white skin caught the emergency lighting in a way that made the faint luminous tracery along her cheekbones and temples pulse softly, like a heartbeat made visible. Her silver hair was cropped close, and her eyes, large and ice blue with faintly glowing rings around the irises, were fixed on the diagnostic display with an expression that managed to be both completely composed and deeply furious. Admiral Sathra Valen, commander of the 7th Fleet, the Welder was her ship. The propagation rate suggests we have approximately 50 to 60 minutes before the plate reaches critical failure, the lead engineer said. If we begin the undocking sequence immediately, there is a reasonable probability that we can clear the vessel before the pylon gives way. Reasonable probability, Valen said. The words landed like stones dropped on glass. 70%, Admiral, perhaps 75%. And the other 25%. Silence, the kind of silence that answered its own question. What about reinforcing the plate? Another engineer asked. If we can brace the fracture by additional time for the undocking. With what? The fracture is in a Class 7 structural mounting plate. The reinforcement would need to be welded directly to the plate under load, which means working beneath a pylon that is actively deforming under 47 million metric tons of pressure. No automated system can perform precision welding in that space. The tolerances are too tight. The magnetic field from the cradle array interferes with drone guidance systems. Then a manual weld. Another silence, longer this time. The weld would need to be a deep penetration fusion, bond on a fracturing plate under active load. The welder would be working in a confined space beneath a pylon that could shift without warning. If the plate fails during the weld, the pylon drops. Anyone beneath it would not survive. Beyond the risk, the lead engineer said carefully, none of our personnel are certified for manual deep penetration welding on structural-grade hull plate. It is not a technique the Thyarren Engineering Corps trains, because our standard practice is to replace damaged structural components rather than field repair them. We do not weld keel-grade plate. We manufacture new plate. Has anyone in the drydock been trained in this technique? Valen asked. The lead engineer hesitated. I can check the personnel roster, Admiral, but the drydock staffing follows fleet engineering doctrine. Our Class 3 engineers are trained in system diagnostics, component replacement, and fabrication oversight. Manual structural welding is not part of the curriculum at any certification level. What about the veteran specialists? Another officer asked. The structural consultants who surveyed the cradle system last quarter. They departed 3 weeks ago. Their report noted that all cradle components were within operational tolerances. The lead engineer paused. It appears their assessment was incorrect. Valen's jaw tightened. The luminous tracery along her temples pulsed once, a dim blue-white flash that faded as quickly as it appeared. Send an automated welding drone, another officer suggested. We have 4 precision units in the fabrication section. They handle hull plate seams during routine assembly. The fabrication drones are designed for flat surface work in zero magnetic environments, the lead engineer said. The cradle array generates a persistent magnetic field rated at 0.72 Tesla at the pylon base. At that field strength, the drone's guidance systems cannot maintain positional accuracy within the tolerances required for a deep penetration weld. We tested this during the Bay 3 refit last year. The drones drifted 11 millimeters per pass. On a structural brace weld, that drift would create an uneven bond line that would fail under asymmetric loading. Reduce the magnetic field. We cannot reduce the magnetic field without releasing the cradle array. If we release the cradle array, the Thyarren drops out of the cradle. That is the outcome we are trying to prevent. Valen's expression did not change, but something behind it compressed, the way a spring compresses before it either releases or breaks. Contact Fleet Command. Ask if there is a structural welding specialist at any installation within emergency transit range. Admiral, the nearest Thyarren installation with a structural repair capability is Dockyard Thyarren, 14 hours at maximum transit speed. We do not have 14 hours. Then contact the civilian contractors, the mining operations in the Varathi Belt, the commercial shipyards. Someone in this sector must have the capability. The communications officer worked the terminal for 2 minutes while the room waited. Kessa watched through the grating, her palm still pressed against the mounting plate. She could feel the vibration increasing. Not dramatically, not the kind of increase that announced itself. The kind that crept millimeter by millimeter, the way a crack creeps through metal when the load never lets up. She had learned to feel the difference between a fracture that was stable and a fracture that was propagating, and this one was propagating. Admiral, I have responses from 3 civilian contractors. The Varathi Mining Consortium has structural welders, but none rated for capital ship-grade alloy. Their experience is limited to mining frame steel, which has a fundamentally different grain structure. Taurus and Yards has a deep penetration welding team, but they are currently deployed on a contract at the outer reach, 6 days out. The third is a salvage operation that specializes in demolition cutting, not precision repair. What about contracting a human welding team from one of the Earth-operated stations? The senior technical advisor asked. It was the first time he had spoken, and his voice carried the careful neutrality of someone who knew he was about to say something that several people in the room would not want to hear. Human shipyard culture maintains manual welding as a core discipline. Their commercial yards still train structural welders in deep penetration technique. It is considered a fundamental competency. The nearest Earth-affiliated station with a commercial shipyard is Thyarren, 7 hours at emergency transit, the communications officer said. And I would need to route the request through the Thyarren Human Liaison Office, which adds processing time. We do not have 7 hours, Valen said. We may not have one. Silence settled over the group again. Through the grating, Kessa could see the lead engineer look at the diagnostic display, then look away, then look back, the way someone looks at a clock when they know the time is running out and looking at it will not slow it down. So we have a fracture that will kill my ship in less than an hour, and our only option is an undocking sequence that has a 1 in 4 chance of failing. Because no one in this facility, no one within emergency range of this facility, and no automated system in our inventory can weld a plate. That is correct, Admiral. Kessa was already moving. She climbed the service ladder to the main bay level, pushed through a maintenance hatch, and walked into the circle of engineers with her tool bag over one shoulder and her welding torch in her right hand. Every head turned. 14 Thyarren engineers in silver-white uniforms, 3 officers in command blue, 2 security personnel, a communications officer, and an admiral whose ice-blue eyes settled on Kessa with the precise, measuring attention of someone who was accustomed to evaluating threats and was now recalculating what category this interruption belonged to. Kessa was aware of what they saw. A human woman, medium height, work-hardened build, wearing stained gray coveralls with a Class 8 contractor badge on the left breast. Her dark hair was pulled back under a welding cap. Her hands were calloused and scarred across the knuckles and permanently darkened with grime that had worked itself into the skin over years. She was holding a Keldric pattern fusion torch, an older model, not military issue, the kind of tool that got passed down through shipyard crews because the newer ones ran hotter but the older ones gave you finer control. "Who are you?" one of the officers asked. "Road, maintenance contractor Class 8. I do pipe welds and hull patches in the secondary bays. This area is restricted to Class 3 and above. How did you get past the security cordon?" "I walked through the maintenance crawlway." The officer's expression shifted, but only slightly. The Thyarren were not a species that wasted facial movement on people below a certain rank. "You need to leave this area immediately." "I can brace that plate." The statement landed in the room like a dropped tool on a quiet deck. Several engineers turned fully to look at her. The officer who had been speaking stopped mid-gesture toward the security personnel. "You are a Class 8 contractor," the lead engineer said. "I am." Class 8 certification covers basic structural repair on civilian vessels below frigate displacement. This is a Class 7 structural mounting plate on a capital ship drydock cradle supporting an Ascendancy-class dreadnought. "I understand what it is. I was just underneath it. I put my hand on the fracture line. You have a fatigue crack propagating from a casting microvoid, probably initiated during the stress cycling from the last 3 docking operations. The microcrack network has spread approximately 8 centimeters on either side of the primary fissure, and the metal at the deformation front is already showing grain distortion. Your automated sensors did not catch it because they are calibrated for critical threshold alerts, not progressive fatigue." The silence that followed was not the contemplative silence of professionals considering an option. It was the stunned silence of people who had just heard a Class 8 pipe welder describe their problem with more precision than their own diagnostic terminal. The lead engineer recovered first. "Even if your assessment is accurate, the weld requires deep penetration fusion bonding under active load in a confined space with significant magnetic interference. Our own engineers are not trained for this procedure." "I know, that is why I am offering." "What is your experience with structural-grade alloy welding?" the lead engineer asked, and there was something in his voice that had not been there before. Not respect, exactly. Curiosity, maybe. The kind of curiosity that a specialist feels when confronted with a competence that exists outside the categories they were taught. 20 years. I started on the floor at Rennick-Hartley Heavy Industries on Earth when I was 18. 11 years there. Naval-grade steel, hull plate, structural frames, keel beams. I welded my first fracture brace under load when I was 26, on a cargo freighter whose spine was buckling in the yard. Then 6 years at Torreson Commercial Shipyard on the outer circuit, where the alloys were different but the physics were the same. 4 years at a fuel depot in the Varathi Belt, field patching hull microfractures on tankers that were too old to retire and too valuable to replace. 9 months here, welding pipes. "You welded a fracture brace under load," the lead engineer said. "On what class of vessel?" "Varden-class cargo freighter, 62,000 metric tons. The starboard frame twisted 9 degrees before the emergency clamps caught it. I braced the mounting plate with a field weld while the clamps engaged, held long enough to save the vessel and the 11 people still aboard." 62,000 metric tons. The Vaithara displaces 47 million. The displacement is different, the metallurgy is different, the scale is different. The physics of a fracture brace under load are not. A crack is a crack. The metal tells you what it wants. You listen or you do not. Admiral Valen had not spoken. She stood slightly apart from the cluster, her arms folded, watching Kessa with those pale, luminous eyes. The faint glow of her iris rings cast small circles of light on her cheekbones. She was tall, the way Thyarren officers tended to be tall, and her stillness had the quality of a blade that had been drawn but not yet swung. "You have done this before," Valen said, not a question. "Once, at this scale this is new. But the principle is the same. And if the plate fails while you are beneath it, then it fails, but it will not fail faster because I am trying to stop it. It will only fail faster if no one does anything." Valen looked at the diagnostic display. The fracture propagation indicator had advanced another 3 millimeters in the time they had been speaking. She looked back at Kessa. "What do you need?" The lead engineer started to speak. Valen raised one hand and the engineer stopped. The hand was slim and pale blue-white, the fingers long, the nails trimmed short and unadorned. It was the smallest gesture Kessa had ever seen silence an entire room. "I need 4 structural bracing plates, 1/2 meter by 1/2 meter, 8 centimeters thick. Same alloy as the mounting plate, or close enough that the weld will bond. I need a secondary power cell for my torch because the one I have will run out before the job is done. I need 2 magnetic clamps rated for structural work, and I need everyone off the service level beneath the pylon. If the plate goes while I am down there, I do not want anyone else under it." "How long?" "The weld itself, 30 to 35 minutes if the fracture cooperates. Setup 10 minutes, call it 45 total. The propagation model gives us 50 to 60 minutes. Then I would rather not spend 15 of them standing here." Something shifted in Valen's expression. It was small, the kind of change that would not register on a face that was less controlled. The faintest easing of the line between her brows, not relief, not approval, something closer to recognition, the look of someone who had just heard a frequency they had not expected to hear. "Get her what she needs," Valen said. The engineers moved. Kessa had expected resistance, protests about protocol, demands for certification documentation, the kind of bureaucratic friction that she had learned to navigate at every posting she had ever worked. Instead, the engineers moved with the crisp, immediate obedience of people who had been given an order by someone they did not question, and the order had been to help the Class 8 pipe welder with the old torch and the scarred hands. They found bracing plates in the drydock structural supply stores. Not the exact alloy but close enough, 90% Vathrium, slightly different carbon lattice ratio. Kessa ran her thumb across the surface of one, feeling the grained structure through her calluses. It would bond, not perfectly, but well enough. The secondary power cell came from the engineering section's emergency reserves. A young Thyarren technician, barely out of training, carried it down to the service level and stood there holding it while Kessa connected it to her torch. His hands were shaking. His pale green-tinged skin had the slightly translucent quality that young Thyarren had before their bioluminescent tracery fully developed, and his eyes, wide and luminous green, watched Kessa's hands as she worked the connection with an intensity that suggested he was memorizing every movement. "What is your name?" "Technician Surith, ma'am." "Surith, have you ever watched a structural weld?" "No, ma'am. We are trained in component replacement, not field repair. I have never seen anyone weld structural plate by hand." "Neither has anyone else in this drydock, apparently." Kessa tightened the last connection on the power cell and tested the torch. The arc lit clean, a tight blue-white point of controlled heat. "When I start, there is going to be light and noise and the smell of burning metal. That is normal. What is not normal is if the pitch of the pylon changes. If you hear the vibration drop by about a half tone, you run. Do not wait for me. Do not come back. You run, and you keep running until you are through the service hatch and on the main level. And you, ma'am. I will be busy. She sent him back up to the main level. Then she was alone on the service level, beneath the forward pylon, with the Thyarren floating above her in its magnetic cradle, and the fracture line running diagonally across the mounting plate like a wound that was still opening. Kessa knelt beside the pylon base and took a moment to read the metal. She pressed both palms flat against the plate, closed her eyes, and felt. The vibration was faster now. The tremor had a jagged quality that told her the microcrack network was branching. She had maybe 50 minutes, maybe less. She mapped the weld pattern in her head. 4 braces, positioned to redistribute the load away from the fracture line and into the solid sections of the plate. The first brace would go on the high-stress side, where the deformation was worst. The second on the opposite side, creating a balanced load path. The third across the widest section of the fracture itself, the hardest weld but the most critical. The fourth as insurance, covering the microcrack network's leading edge. The space was tight. She had to work on her back, her torch held above her at an angle, her face 18 inches from the plate. The magnetic field from the cradle array pressed against her like a low-grade headache, a constant hum in her teeth and her sinuses that made her eyes water and her jaw ache. Through her visor she could see the fracture in sharp detail. Not a clean line, but a branching network of microcracks radiating from a central fissure, the metal deformed outward along the edges, the grain structure visibly distorted under the load. She positioned the first bracing plate, clamped it, checked the alignment, adjusted it 2 millimeters to the left because the fracture was propagating in that direction and she needed the brace to lead the crack, not chase it. She checked the clamp pressure, adjusted it down slightly, because over-clamping on a plate under load would create a new stress concentration point. And the last thing she needed was to fix one fracture by starting another. Then she struck the arc. The torch was old, but it was hers. She had rebuilt it twice, replaced the focusing element once, recalibrated the plasma feed with a hand wound coil because the factory replacements ran too hot for fine work. The arc caught clean, a tight blue-white cone of focused heat that bit into the Thyarren plate and began fusing the brace to the mounting surface. Deep penetration welding was not about heat, it was about patience. You fed the arc into the metal slowly, letting the fusion zone develop layer by layer, each pass building on the last, the brace becoming part of the plate the way a bone graft becomes part of the skeleton. Too fast and the bond was shallow, a surface weld that would crack under load before the shift ended. Too slow and the heat bled into the surrounding metal, weakening the grain structure around the fracture and making the problem worse than it was before you started. The sweet spot was a rhythm, a cadence that the metal set and the welder followed, and finding that cadence was not something you could learn from a manual or a certification program. You learned it the way a musician learns to play by ear. You listened. You felt. You let the metal tell you what it needed. Kessa found the rhythm in the first 30 seconds. The Thyarren was different from what she was used to. Lighter, more responsive. It wanted less heat and more time, which was the opposite of terrestrial steel, and for a moment she had to recalibrate everything she knew, adjusting her feed rate, her torch angle, her breathing, until the metal stopped fighting her and began to cooperate. The fusion zone developed smoothly after that, a clean bead of bonded metal tracking along the edge of the brace plate, sinking into the mounting plate layer by layer, molecule by molecule. The first brace took 9 minutes. She ran her hand across the bond line when it cooled, feeling for imperfections with the tips of her fingers, the same way she had been taught by Hal Rennick himself in the second year of her apprenticeship. Old Hal, who had hands like leather gloves and a voice like a diesel engine, and who had told her, on her 3rd day on the floor, that a welder who could not feel a flaw in a bond line through her fingertips had no business holding a torch. Smooth. Clean. The grain structure had fused properly. The brace locked to the plate in a bond that would hold against the load, as long as the surrounding metal did not deteriorate further. She allowed herself one breath, then she moved to the second position, reset, clamped. Checked the alignment twice because the second brace had to mirror the first exactly, creating a symmetrical load path that would prevent the fracture from pivoting around a single reinforcement point. Arc. Above her, through the grating, she could hear movement. The engineers had not left. She caught fragments of their conversation, filtered through the hum of her torch and the deeper vibration of the straining pylon. The fracture propagation has slowed. By how much? 14% in the last 4 minutes. The first brace is redistributing the load across a wider section of the plate. That should not be possible with a field weld. The bond strength of a manual fusion weld is theoretically 60 to 70% of a factory bond. A 14% reduction in propagation rate would require a bond strength of at least 85%. The stress readings disagree with the theory. Kessa did not smile, but something in her settled, a quiet confirmation that the metal was cooperating, that the rhythm was right, that 20 years of work on floors that nobody noticed had built something in her hands that no certification program could replicate. She thought of Hal Rennick, who had taught her to weld before she was old enough to legally sign for her own tools, and who had told her once, while they watched a factory-made weld crack under load during a stress test, that the difference between a weld that held and a weld that cracked was not in the torch or the alloy or the specifications. It was in the person. A machine welded to a number, a person welded to the metal. She thought of the Rennick-Hartley yard closing 8 years ago, the gates chained and the lights killed, and the machinery sold for scrap to a salvage company that paid 13 cents on the dollar. She had been 4 years gone by then, already on the outer circuit, but she had heard about it from a former colleague who had stayed. The last welder to leave had been a woman named Das, 61 years old, who had worked the floor for 38 years, and when she walked out she had left her torch on the workbench because she said the torch belonged to the yard, not to her. Kessa had carried her own torch with her because Hal had given it to her on her last day, pressing it into her hands with fingers that were already losing their strength to arthritis, and saying, "You are going to need this more than I will. Take care of it and it will take care of you." She was taking care of it, and it was taking care of her. The second brace took 8 minutes. She was faster now, the rhythm established, her hands moving with the automatic precision that came from doing something so many times that the conscious mind stepped aside and let the muscle memory run the process. Her back ached from the angle. The magnetic field was giving her a headache that pulsed in time with the cradle emitters. Sweat ran down her temples and pooled against the seal of her visor, and the skin on her forearms prickled from the proximity to the arc. She did not stop. The third brace was the critical one. She positioned it directly across the widest section of the fracture, where the micro-crack network was densest and the deformation was most severe. The metal here was hot to the touch, not from her torch but from the internal stress, the molecular friction of a plate that was trying to tear itself apart under a load it had never been designed to bear for this long. She could feel it through her gloves, a warmth that had no business being there. And when she pressed her fingertips against the surface, she could feel the grain structure pulsing, a micro-tremor that ran through the crystalline lattice like a warning. She adjusted her torch angle, dropped her feed rate by 15%. The metal here needed gentleness, not force. It was already at its limit. Pushing harder would fracture it faster. She had to coax the brace into place, let the fusion bond develop slowly, let the heat dissipate into the surrounding structure at a rate the metal could absorb without losing cohesion. 4 minutes in, one of the engineers above said something that carried down through the grating with the clarity of bad news delivered in a quiet room. The secondary cradle pylon is showing sympathetic stress. The load redistribution from the first 2 braces is transferring lateral force into the adjacent mounting. How much? 0.3% above nominal, not critical, but if the primary plate fails, the secondary will follow within 90 seconds. Kessa heard it. She did not react. Her hands kept moving, the arc steady, the bead tracking clean along the brace plate edge. She had learned a long time ago, on a shipyard floor where things went wrong regularly, and the people who panicked were the ones who made mistakes, that the best thing you could do when the news got worse was narrow your focus to the 6 inches of metal in front of you and let the rest of the world sort itself out. 7 minutes in, the pylon groaned. A deep, resonant sound that vibrated through the mounting plate and into Kessa's back and ribs like a struck bell. The fracture had jumped. Not much. 3 millimeters. But 3 millimeters in a plate under this kind of load was the difference between holding and not holding, and for one long second Kessa felt the plate shift beneath her, the braces she had already welded taking the load, the metal screaming silently through her palms. Above her, someone said, "The propagation rate just spiked. She needs to get out." Someone else said, "Admiral." Valen's voice, calm and flat, "Let her work." Kessa held her arc steady, did not flinch, did not pull back. The bead of molten metal at the tip of her torch wavered once as the plate shifted, and she corrected with a movement so small it was barely a movement at all, just a thought translated through her wrist and into the torch and into the metal. The fusion zone restabilized. The bead tracked clean. The groan subsided, the plate held. She finished the 3rd brace in silence, her breathing measured, her hands steady, her heartbeat the only clock she was willing to listen to. The 4th brace went on in 6 minutes. She placed it at the leading edge of the microcrack network, where the fracture would go next if it decided to keep growing, and she welded it with a feed rate that was slower than any she had used in 20 years, because this brace was not about holding the current load. It was about telling the metal where it could not go, a boundary, a wall built into the grain structure that said this far, no farther. Between the 3rd and 4th braces, Kessa paused. She pressed her palms against the mounting plate again, reading the metal through her calluses. The vibration had changed. Before, it had been jagged, irregular, the tremor of a structure that was losing its fight against the load. Now it was smoother, more rhythmic, the kind of vibration that said the structure was working again, redistributing the stress through the new load paths the braces had created. The fracture was still there. It would always be there until the plate was properly replaced in a controlled maintenance cycle, but it was no longer growing. It was contained. The metal was holding, and the metal knew it was holding, and the difference between those two states was something that no diagnostic terminal could measure and no engineering manual could describe. But Kessa could feel it through her hands the way a doctor could feel the difference between a pulse that was failing and a pulse that was fighting. She positioned the 4th brace, clamped it, and struck the arc for the last time. By the time she killed the arc and lifted her visor, her arms were trembling and her coveralls were soaked through with sweat, and the headache from the magnetic field had settled behind her eyes like a second skull pressing against the first. Her shoulders burned. Her lower back had gone past aching into a dull numbness that she knew from experience would become something much worse in about 2 hours. She lay on her back for 10 seconds, looking up at the underside of the pylon. The 4 braces gleamed dully in the emergency lighting, each one fused to the mounting plate in a clean, tight bond that followed the fracture line the way a suture follows a wound. The metal had stopped groaning. The vibration through the structure had changed pitch from the deep, arrhythmic pulse of a system failing to the steady, low hum of a system under strain but holding. Holding. She gathered her tools. The power cell was at 11%. The torch had held. She had rebuilt that torch 3 times over the years, replacing every component except the handle, which was the original handle from the Keldrick factory, worn smooth by her grip and the grips of the 2 welders who had carried it before her. It was not a valuable tool. It was not a rare tool. It was a tool that had been kept working by people who believed that keeping things working was what you did, because, Letting things break was not an option when you were the person standing closest to the break. She climbed the service ladder, her arms protesting every rung, and pushed through the maintenance hatch onto the main bay level. The engineering cluster had grown. Where there had been 14 engineers and a handful of officers, there were now closer to 30 people, including additional engineering teams that had arrived from other sections of the drydock. 2 senior officers in dress uniforms who looked like they had been pulled out of an administrative function, a medical team standing by with emergency kits, and a cluster of civilian dock administrators who had gathered near the observation window with the expression of people who were trying very hard to look like they were supposed to be there. And at the center, Admiral Valen, standing exactly where Kessa had left her, in the same posture with the same controlled expression, watching the diagnostic display. The display told the story. The fracture propagation had stopped, not slowed. Stopped. The stress distribution across the mounting plate had shifted completely. The load now spread across the 4 bracing points in a pattern that reduced the peak stress on the fracture line by 43%. The secondary pylon sympathetic stress readings had returned to nominal. The Thyarren's positional stability in the cradle was holding within 1/10 of a degree. The ship was not going to fall. Nobody spoke for a moment. The kind of moment that happens when a room full of people who had been preparing for a catastrophe realizes that the catastrophe is not going to happen, and the reason it is not going to happen is standing in front of them in stained coveralls with a welding torch clipped to her belt and sweat still drying on her face. The lead engineer broke the silence. He was looking at the diagnostic display with an expression that Kessa had seen before on the faces of people who were being told something by their instruments that their training said should not be true. The bond strength on the bracing welds is reading at 91% of factory specification. That is not possible, another engineer said. Manual fusion welding under field conditions cannot achieve above 70%. The theoretical maximum with optimal torch calibration and ideal conditions is 74%. The instruments are calibrated. I ran the diagnostic twice, 91%, on all 4 braces, consistent across the entire bond line. The alloy was not even a precise match. The carbon lattice ratio was off by 2%. I am aware the readings are what they are. A third engineer, older than the rest, with the rank insignia of a senior technical advisor, stepped forward and examined the display more closely. His pale silver skin caught the light as he leaned in, and his expression went through a sequence of changes that tracked in order: disbelief, confusion, recalculation, and something that looked like the beginning of professional humility. She compensated for the alloy mismatch in the feed rate, he said quietly. The fusion profile on the 3rd brace, the one across the fracture, the heat distribution is not uniform. She varied the penetration depth across the weld, deeper where the grain distortion was worst, shallower where the plate was still structurally sound. That is not a standard technique. I have not seen it in any engineering reference. Because it is not in any engineering reference, Kessa said. It is something you learn on a shipyard floor when the alloy you are given is not the alloy you wanted, and the manual does not cover what you are doing, and the only thing that matters is whether the weld holds. The senior advisor was quiet for a moment. Then he looked at Kessa with an expression she had never seen directed at her in 9 months at this drydock, or 4 years at the fuel depot, or 6 years at the commercial yard. It was the expression of a professional who recognized another professional, not a contractor, not a Class 8, a professional. I would very much like to see the technique demonstrated in controlled conditions, he said, with instrumentation, if that could be arranged. If you have a piece of scrap plate in an hour, I can show you, Kessa said. He nodded, just that, a nod, But it was the kind of nod that meant something had changed in the room, quietly, the way important things always changed, not with a declaration but with a recognition. The young technician, Sureth, was standing at the edge of the group. He was looking at Kessa the way someone looks at a thing they have never seen before and are not sure they have a category for. His luminous green eyes tracked from her face to her hands to the torch on her belt and back to her face. "How?" he asked, just the one word. "The metal tells you what it wants," Kessa said. "You just have to listen." It was the kind of answer that would have meant nothing to most people in the room. Sureth nodded slowly, as if it meant everything. Admiral Valen stepped forward. The cluster of engineers and officers parted for her with the automatic deference of people who had been parting for her their entire careers. She stopped 2 meters from Kessa and stood there for a moment, her ice-blue eyes taking in the stained coveralls, the scarred hands, the old torch, the welding cap pushed back on Kessa's head, the sweat still drying on her temples. The luminous tracery along her cheekbones pulsed once, slowly, and in the emergency lighting it gave her face a quality that was almost gentle, which was not a word that anyone who served under Admiral Valen would have thought to use. Contractor Road. "Admiral, my chief engineer tells me that what you just did should not have been possible. With respect, Admiral, your chief engineer has not spent 20 years welding hull plate on freighters and fuel tankers. The things you learn on those jobs are not the things they teach in fleet engineering programs. They are the things you learn because something is broken and nobody else is coming to fix it, and the only tool you have is the one in your hand." Evidently not. Valen was quiet for a moment. The bay hummed around them, the Thyarren floating steady overhead, the emergency lighting beginning to cycle back to normal as the automated systems registered the stabilization. One by one, the amber strobes dimmed, replaced by the standard white-blue illumination of the main bay lights. When Valen spoke again, her voice had changed. Not softer, not warmer, something else. Something that sounded like a decision being made in real time, and the decision was important enough that she wanted it heard clearly. "I am going to make you an offer. I want you to understand that it is genuine, and that it carries my personal authority, and that nothing about it is provisional." Kessa waited. The 7th Fleet has 31 vessels. They are serviced by 412 engineers, all of them Class 3 or above, all of them trained in component replacement and system diagnostics. Not one of them can do what you just did. Not one of them has ever been trained to do what you just did. The Thyarren engineering doctrine is to replace, not repair. We build new parts. We do not fix old ones. It is a doctrine that works when the supply chain is functioning, and the fleet is not overstretched, and every installation has a factory producing components faster than they degrade. It does not work in the field, where parts do not arrive on time, and ships cannot wait in drydock for a factory to manufacture a new mounting plate. She paused. The engineers around her were very still. Kessa noticed that the senior technical advisor, the older one who had analyzed her weld profile, was watching Valen with an expression that suggested he already knew where this was going, and was calculating what it meant for the engineering corps. "I am offering you a position as Fleet Structural Repair Specialist, reporting directly to my office. You would carry a Class 1 certification, the highest in the fleet. You would have authority to perform field repairs on any vessel in the 7th Fleet, including capital ships, including this one. You would train a team. You would write the manual that my engineers should have had 20 years ago. The position comes with full fleet officer standing, quarters aboard any vessel of your choosing, and a salary commensurate with the rank." The silence in the bay was absolute. Kessa could hear the Thyarren's hull ticking as the thermal stresses equalized, a sound like a large animal settling into sleep. She could feel every eye in the room on her, 30-odd people, engineers and officers and administrators and medical staff, all looking at the Class 8 pipe welder who had just been offered a position that did not exist an hour ago. She thought about it. She thought about Fleet Structural Repair Specialist and Class 1 certification and reporting directly to the Admiral's office. She thought about writing the manual and training the team and having her name on documents that people above Class 8 would actually read. She thought about the 11 years at Rennick-Hartley and the 6 years on the outer circuit and the 4 years at the fuel depot and the 9 months in the secondary bays of this drydock, welding pipe patches and swapping relays and being invisible. And she thought about Bay 14, about the cracked manifold pipe she had been patching when the alarms went off, about the coolant junction that was still leaking thermogel into the deck drainage because nobody had filed the repair order and nobody was going to file the repair order. She thought about all the Bay 14 she had worked in, across 20 years and a dozen postings. The forgotten bays, the secondary systems, the small failures that nobody tracked because they were not catastrophic yet, just slowly, patiently becoming catastrophic while the polished concourses above stayed polished and the diagnostic terminals above stayed green. The relay in Bay 7 that she had fixed 3 weeks ago because the automated priority queue had not ranked it high enough. The hot spot in the crawlway conduit she had taped on her way here. 45 seconds of work that would prevent 4 bays from losing their emergency lighting in a month. The splice joints and gaskets and mounting brackets she had tended across 9 months, none of them logged, none of them reported, none of them visible to anyone who did not walk the crawlways and put their hands on the metal and feel what was there. That was the work, not the big repair under the big ship with the Admiral watching. That was the exception. The work was the 1,000 small repairs that nobody asked for, and nobody noticed and nobody thanked you for, done day after day in the spaces between the polished concourses, keeping the infrastructure alive while the people who walked above it took it for granted. If she took the title and the Class 1 badge and the officer's quarters and the salary, she would spend her days on capital ships and flagships and the vessels that mattered to admirals. And the Bay 14s would go back to being invisible, the way they had been before she arrived, and the small failures would creep back. And in 6 months or a year, another mounting plate would start to fracture in another drydock, and there would be nobody in the crawlway to feel it happening. Admiral, I appreciate the offer, I do, but I would like to ask you something first. Ask. Bay 14 has a coolant junction that has been leaking for 2 shifts. Nobody filed the repair order because Bay 14 services freight haulers, and freight haulers are not priority vessels. There are 6 other bays in this drydock with similar issues. Pipes that leak, relays that fire intermittently, seals that are degrading, mounting brackets that are taking cyclic stress loads they were never designed for. Small things. The kind of things that do not show up on anyone's diagnostic display until they become the kind of things that make alarms go off and pylons fracture and admirals lose their flagships. Valen said nothing. She was watching Kessa with the same measuring attention she had shown since the beginning, but something in it had shifted. A quality of listening that went beyond hearing, past the words and into the thing behind the words, the way a good officer listens when someone is telling them something they need to know but have not known how to ask for. Your fleet has 400 engineers who can replace a component when the diagnostic terminal tells them it has failed. What it does not have is anyone who walks the secondary bays and catches the small failures before they become big ones. The mounting plate in that pylon did not fracture today. It started fracturing weeks ago, maybe months ago, in micro stresses that nobody was looking for because nobody walks the structural service levels on a routine inspection. Nobody checks the mounting plates by hand. Nobody puts a palm on the metal and feels whether the grain is holding. Kessa paused. The bay was very quiet. I will take the position, but not the title, not the Class 1 badge. I do not need a certification number on my chest to do the work. What I need is access. Let me walk your ships the way I walk these bays. Let me put my hands on the metal and find the problems before they find you. And when I find something that needs fixing, let me fix it with this." She held up the torch, the old Keldric pattern with the hand-wound coil and the rebuilt focusing element. Not a requisition form, not a work order, not a committee, just the tool and the metal and the time to do it right. "You want to remain a contractor." "I want to remain a mechanic. That is what I am. The title does not change the work. The work is what matters." Valen looked at Kessa for a long time. The luminous lines along her temples pulsed twice, 3 times, in a rhythm that seemed almost contemplative, as though the bioluminescence was tracking some internal process that had no external name. The engineers around them had the frozen quality of people who were witnessing something they did not have a framework for. The young technician, Sureth, had his lips slightly parted. Then Valen did something that Kessa had never seen a Thyarren flag officer do. She extended her hand, not in the Thyarren formal salute, which was a closed fist pressed to the sternum. In the human way, an open hand offered at waist height, palms slightly upward. "Walk my ship's mechanic road, find what no one else is looking for." Kessa took the hand. Valen's grip was cool and dry and surprisingly strong, and the luminous tracery beneath her pale skin pulsed once against Kessa's callous palm, a sensation like touching a live current at very low voltage, intimate and startling and gone in a second. "I will need someone to show me where the service crawlways are on a dreadnought," Kessa said. "They are probably not labeled." "They are not." Valen released her hand. The ghost of something that was not quite a smile passed across her features. "Sureth." The young technician straightened as if someone had run a current through his spine. "Admiral. You are assigned to Mechanic Road, effective immediately. Go where she goes, learn what she teaches. And get her a power cell that does not require recharging every 40 minutes. "Yes, Admiral." Valen turned and walked toward the bay exit. At the threshold she paused and looked back, not at the diagnostic display, not at the engineers, at Kessa. "Mechanic Road, one more thing." "Admiral." "The automated sensor system on the cradle pylons, the one that did not detect the fracture until it was nearly too late. What would you recommend?" Kessa thought about it for 2 seconds. "Walk the pylons, once a week, by hand. Put a palm on every mounting plate and feel the grain. If the grain is holding, you move on. If it is not, you fix it before it becomes a problem. A person costs less than a pylon." "And who walks them?" "Anyone you train to feel what the metal is saying. It takes about 6 months to develop the touch, if you start them young and they pay attention." Valen looked at Sureth. Sureth looked at Kessa. Something passed between them that did not require words. Then Valen turned and walked out, her officers falling into step behind her with the practiced synchronization of people who had spent years matching her pace. The bay doors closed behind her, and the room shifted, the formal tension of an admiral's presence replaced by the lower frequency buzzing of people who had too much to process and not enough categories to process it in. The senior technical advisor was already at the diagnostic terminal, running a detailed analysis of the weld profiles. He had pulled up a comparative display, placing Kessa's field welds alongside the factory specifications for the original mounting plate, and his expression as he studied the overlay was the expression of a man whose professional framework was being quietly, thoroughly rearranged. "The penetration depth on the third brace varies by as much as 4 millimeters across the weld line," he said, half to himself and half to anyone listening. "But the variance is not random. It follows the grain distortion pattern of the plate." She read the distortion through the surface and adjusted the penetration to match, in real time, with an analog torch and no diagnostic feedback. "That is not a technique," one of the junior engineers said. "That is something else." "It is a technique," the advisor said quietly. "It is simply one we have never codified, because we have never met anyone who could perform it." 2 junior engineers were crouched at the maintenance hatch, peering down into the service level, as though the braces she had welded might tell them something their training had not. One of them reached down and touched the nearest brace plate, running his fingertips along the bond line the way Kessa had done. He pulled his hand back and looked at his fingers, then looked up at his colleague with an expression that said the metal was smooth, and he did not understand why that mattered, and he wanted to understand. The lead engineer approached Kessa. He was a tall Thyarren with close-cropped silver-white hair and the kind of face that had been trained from birth to reveal nothing, but the training was struggling. Something in his eyes had shifted. Not respect, not yet. Something before respect. The recognition that respect might be warranted, and the internal rearrangement required to make room for it. Contractor Road, for the record, I want you to know that I will be filing a commendation report with the Fleet Engineering Directorate. What you accomplished today was outside the scope of any procedure I have been trained in, and the results exceeded any parameter I would have considered achievable. The Directorate should know that a gap exists in our training doctrine, and that today it was filled by someone who was not part of our program. Appreciated, Kessa said. But I would rather you file the repair orders for bays 6, 7, 11, and 14. There are 17 items in those bays that need attention before they become the kind of problem that brings admirals to the concourse. The engineer blinked, slowly, the way Thyarren blinked when something had landed in a place they were not expecting it to land. I will look into it, he said. Kessa nodded. She did not say what she was thinking, which was that looking into it and doing it were two different things, and that the gap between them was where most of the failures she had spent her career fixing had been born. She had learned, across 20 years and a dozen postings, that you could not change a system by telling it what was wrong with it. You could only change it by being the person who fixed what the system would not fix, day after day, until someone noticed. Young Surith was standing at the edge of the group, his tool bag slung over one shoulder in an unconscious mirror of the way Kessa carried hers. He was looking at her with an expression that she recognized from decades of work in places that did not notice her, across a dozen postings and more secondary bays than she could count. It was the look of someone who had just realized that the invisible person in the room was the one holding everything together. Kessa clipped her torch to her belt, picked up her tool bag, and nodded toward the service hatch. Come on, Surith. We have a coolant junction to finish in Bay 14. Yes, Mechanic Road. He hesitated. Ma'am, the thing you said about the metal telling you what it wants, how do you learn to hear it? Kessa looked at him. He was young. His hands were clean and his coveralls were unstained and his nails had never known grease that would not come out. But his eyes were steady and the question was real. You put your hands on the metal, she said. Every day. You listen. You pay attention to what is there instead of what the manual says should be there. And you do not skip the things nobody asks you to do. That sounds like it takes a long time. It takes a career. But it starts today. She nodded toward the hatch. Bay 14. The coolant junction is not going to fix itself. They walked together into the maintenance crawlway, the young Thyarren technician and the human welder, leaving the Flagship and the Admiral and the diagnostic displays behind them. The crawlway was dim and warm and smelled like thermogel and old insulation, and the emergency lighting strips cast long amber shadows along the conduit-lined walls. Kessa moved through it with the practiced ease of someone who belonged there, and Surith followed, watching her feet and her hands, and the way she paused at every junction box they passed, pressing a fingertip against the casing for half a second before moving on. What are you checking? He asked after the third one. Temperature. Vibration, whether the seal is holding, whether the connection has shifted. Everyone I pass. It takes half a second. If something is wrong, I fix it. If nothing is wrong, I know it is fine and I move on. The system does not check these junctions on a routine schedule. Nobody does, so I do. Surith was quiet for a moment, absorbing this. Then he pressed his fingertip against the next junction box they reached, held it there for a full second and said, "This one is warm." Kessa stopped. She turned back, placed her own hand on the casing, and felt the faint heat of a relay running above its rated current, probably from a corroded contact inside the junction. She looked at Surith. "Good. When we finish in Bay 14, we will come back and fix it." The look on his face was not gratitude, exactly. It was something more fundamental than that. It was the look of someone who had just been given permission to care about something that the system he lived inside had never thought to ask him to care about. They continued through the crawlway toward Bay 14. Above their heads, the Thyarren floated steady in its magnetic cradle, the four bracing welds holding firm, the fracture sealed, the pylon quiet. Somewhere in the drydock's secondary bays, a pipe was still leaking. Kessa would get to it. She always did. Bay 14 was exactly the way she had left it. The coolant junction was still leaking, a thin steady drip of blue-green thermogel pooling on the deck plating beneath the manifold pipe, spreading in a widening stain that nobody had mopped up because nobody had been in Bay 14 since Kessa left it 47 minutes ago. The welding arc she had killed when the alarm started was still visible on the patch she had been applying, a half-finished bead of fused metal that stopped midline like a sentence abandoned in the middle of a word. She knelt beneath the junction, repositioned the patch plate and struck the arc. Surith stood 3 meters behind her, watching. He had not said anything since they entered the bay, and Kessa appreciated that. Some people filled silence with questions because they were nervous, and some people filled silence with questions because they wanted to learn, and the difference between the two was that the second kind knew when to ask and when to watch. Surith was watching. His luminous green eyes tracked the movement of the torch the way a student of music might watch a master's fingers on an instrument, not trying to replicate the motion, but trying to understand the principle beneath it. The patch took 4 minutes, a simple job. The manifold pipe was standard commercial-grade Durasteel. The crack was a straightforward fatigue fracture from thermal cycling, and the weld was a surface fusion bond that any first-year apprentice at Rennick Hartley could have performed. After the mounting plate beneath the Thyarren, it felt like writing her name after composing a novel. But the thermogel had stopped leaking, and the junction was sealed, and the next time a freight hauler docked in Bay 14 and the crew ran their coolant systems, the pipe would hold. That mattered. Not the way a flagship mattered to an admiral, but the way infrastructure mattered to the people who depended on it without knowing they depended on it. "Hand me the sealant cartridge," Kessa said. "Left pocket of the tool bag, cylindrical gray cap." Surith found it on the second try. His hands moved with the careful deliberateness of someone who was learning the geography of a new toolkit, cataloging each item's shape and weight and position. He handed the cartridge to Kessa without fumbling, which was better than most new assistants managed on their first day. She had worked with apprentices at Rennick Hartley who could not find a wrench in their own bag after 6 weeks. She applied a ring of thermal sealant around the patch margin, smoothing it with her thumb. The sealant would cure in the ambient heat of the bay and form a secondary barrier against thermogel leakage, buying the patch another 2 to 3 years of service life beyond the weld alone. It was an extra step. It was not in any manual. It was a habit she had developed at the fuel depot in the Varathi belt, where the thermogel vapor corroded weld margins at twice the rate of standard environments, and a patch without sealant backup was a patch that would need redoing in 6 months. "Why the sealant?" Surith asked. The first question he had asked since they started working, and he had waited until she was between tasks to ask it, which told her that he had been thinking about it for at least 3 minutes and had chosen not to interrupt. "The weld will hold on its own, but thermogel vapor attacks the bond margin over time. The sealant gives you a buffer. In 2 years, when the weld margin starts to degrade, the sealant will still be intact, and someone will have time to redo the patch instead of discovering a leak during a critical operation." You are building in redundancy. I am building in time. Time for someone to notice and time for someone to fix it. The difference between a system that fails and a system that holds is usually not strength. It is time. If you give the system enough time to be maintained, it will hold. If you do not, it will fail, and someone will blame the design when the real problem was that nobody checked it between the day it was installed and the day it broke. Surith was quiet for a moment. Then he said, "Nobody checks the secondary bays on a regular schedule." The automated systems prioritize by bay classification. Bay 14 is Class 7, which means maintenance requests are reviewed on a 30-day cycle. I know. You have been checking them yourself. Every day. For 9 months. For 9 months, and for 4 years at the fuel depot before that, and for 6 years at the shipyard before that. The bays change. The station changes. The schedule stays the same. Walk the bays, touch the metal, find what is breaking before it breaks. And nobody asked you to. Nobody has ever asked me to. Not once at any posting in 20 years. The work gets done because I do it. The system does not know it needs doing because the system is designed to notice catastrophic failure, not the slow creep that leads to catastrophic failure. There is a gap between what the system tracks and what actually needs attention. I live in that gap. She packed her tools and stood, pressing one hand against the small of her back where the numbness from the pylon work was beginning to convert into a deep, grinding ache. Her shoulders protested. Her arms felt heavier than they should have. The headache from the magnetic field had settled into a persistent pressure behind her eyes that she knew from experience would take about 12 hours to fully dissipate. She had been awake for 14 hours. She had welded 4 structural braces on a capital ship mounting plate under conditions that the Thyarren Engineering Corps had officially classified as impossible. And now she was back in Bay 14, doing the job she had been doing when the alarms went off, because the job was not finished and leaving a job unfinished was not something she did. "What is next?" Surith asked. Kessa consulted the mental list she maintained, the one that lived nowhere except inside her head, because writing it down would require filing it through the drydock's maintenance queue, and the queue would deprioritize most of it into oblivion. 14 items across 6 bays, accumulated over 3 weeks of daily crawlway inspections. 3 of them were urgent in the sense that they would cause problems within the next 10 days if left unaddressed. 8 of them were medium-term, things that would degrade over the next month or 2. 3 of them were preventive, things that were not broken yet but showed the early signs of becoming broken if the conditions that were stressing them were not addressed. Bay 11. There is a pressure regulator on the atmospheric feed line that is cycling faster than spec. It is compensating for a slight leak in the downstream coupling. If we fix the coupling, the regulator will stop overcycling, which will extend its service life by about 18 months. And if we do not fix the coupling, the regulator burns out in 3 to 4 weeks. When it burns out, the atmospheric feed to Bay 11 fluctuates. The fluctuation will not be dangerous, not immediately. But it will create micropressure variations in the bay environment that will stress the hull seals on whatever vessel is docked there. If the vessel is a corvette with standard seals, it will be fine. If the vessel is something older with degraded seals, the micropressure variations could cause a slow atmospheric bleed that nobody will notice until the crew starts getting headaches from oxygen depletion. All of that from a coupling leak. All of that from a coupling leak. Everything connects. Every system feeds into every other system. The leak affects the regulator. The regulator affects the atmosphere. The atmosphere affects the seals. The seals affect the crew. The chain is always there. The only question is how many links you can see. They walked through the maintenance crawlway, past junction boxes that Kessa checked with a fingertip as she passed, into the service corridor that connected bays 11 through 16. The drydock had returned to something approximating normal operations, though the normal had a different texture now. As they passed through the lower concourse, Kessa noticed a pair of Thyarren engineers standing at the entrance to a service crawlway hatch, peering into it with the expression of people who had just realized that a door they had walked past 1,000 times led somewhere they had never thought to look. One of them glanced at Kessa as she passed, and the glance held for a beat longer than it would have an hour ago. She did not acknowledge it. Acknowledgement was not the point. The point was the coupling in Bay 11. The coupling was exactly where she expected it to be, 12 meters up the atmospheric feed line, accessible from the maintenance catwalk that ran along the upper wall of Bay 11. The leak was small, a hairline seep at the coupling's compression ring, barely visible as a faint sheen of condensation on the downstream side. Without instrumentation, you would not notice it unless you were looking for it. Kessa had noticed it 6 days ago, during a routine crawlway check, because the condensation pattern on the feed line did not match the ambient humidity profile of the bay. The metal was slightly wetter than it should have been, and the wetness was localized, and localized wetness on a feed line meant a leak upstream. She showed Surith how to identify the leak by touch, pressing his fingertips against the coupling and feeling for the subtle vibration of pressurized gas escaping through a gap that was too small to see but not too small to feel. His hands were steadier than she expected. His fingers found the vibration on the third try, and his eyes widened slightly when he felt it, the way someone's eyes widen when they discover a sense they did not know they had. "I feel it," he said. "It is like a pulse, very faint." That is the gas escaping through the compression ring. The ring has deformed slightly from thermal cycling. The deformation is less than 1/10 of a millimeter. You cannot see it. You cannot measure it with a standard gauge. But you can feel it, because pressurized gas moving through a microgap creates a vibration pattern that is different from the ambient vibration of the feed line. How do you know the difference? Experience. The feed line has a baseline vibration from the gas flow. It is steady and even. The leak vibration is irregular because the gas is turbulent as it passes through the gap. The turbulence creates a pattern that your fingertips can distinguish from the steady flow. It takes practice. Start by learning what normal feels like, and then everything that is not normal will announce itself. She fixed the coupling in 7 minutes, removed the compression ring, cleaned the seating surface, installed a replacement ring from the spares she carried in her tool bag. The spares were not standard issue. They were parts she had accumulated over 9 months, sourced from decommissioned fittings she found in the drydock salvage bins. The drydock supply system would have provided a replacement ring on request, but the request would have gone through the procurement queue, which was managed by the same prioritization algorithm that managed the maintenance queue, and a compression ring for a Class 7 bay atmospheric feed line was not a priority item. The ring would have arrived in 10 to 14 days. The coupling would have continued leaking for 10 to 14 days. The regulator would have continued overcycling for 10 to 14 days. And the chain of consequences would have advanced 10 to 14 links further toward the endpoint that nobody was watching for. Kessa did not wait for the system. She carried the parts and she did the work, and the system caught up when it caught up, if it caught up at all. As she finished the coupling repair, the drydock's internal communication system chimed. A message, routed to her contractor badge, from the Fleet Engineering Directorate. She read it on the small screen embedded in her badge while Surith cleaned up the work area. It was a formal notice. Her contractor classification had been revised, not to Class 1, as Valen had offered, to a new designation that had not existed 20 minutes ago, Fleet Infrastructure Specialist, unclassified. The designation carried no numerical rank. It carried no formal place in the Thyarren engineering hierarchy. What it carried was a single line of authorization text that Kessa read twice, because the first time she read it she was not sure she had understood it correctly. Bearer is authorized unrestricted access to all fleet and drydock facilities, systems, and vessels for the purpose of infrastructure assessment and field repair. Authorization issued by Admiral Sathra Valen, Commander, 7th Fleet. No expiration. No expiration. Kessa looked at that phrase for a long moment. In 20 years of contract work across a dozen postings, she had never held an authorization that did not have an expiration date. Every badge she had ever worn came with a term limit, a renewal requirement, a periodic review. The system assumed that access was temporary, that contractors came and went, that the work they did was transactional and bounded and would end when the contract ended. Valen had removed the boundary. "What is it?" Surith asked, noticing her stillness. "New badge authorization. The Admiral decided I did not need a title, but she gave me a key to everything." Everything. Every ship, every bay, every crawlway, every service level on every vessel in the 7th Fleet. Kessa clipped the badge back to her coveralls. "Which means our list of 14 items just got significantly longer." "How much longer?" 31 ships. Each one with its own crawlways, its own service levels, its own junction boxes, its own mounting plates, its own slow failures that nobody is looking for. She picked up her tool bag. "We should start making a schedule." The weight of it settled on her as she said it. Not the weight of burden, but the weight of scope. 31 vessels, 412 engineers who had never been taught to feel the metal. An entire fleet's worth of mounting plates and compression rings and splice joints and relay boxes, all of them aging, all of them cycling, all of them subject to the slow accumulation of micro-stresses that would eventually, inevitably, produce the kind of failure that brought admirals to the concourse and made emergency lights strobe amber across a flagship's hull. She could not check them all, not alone, not even with Surith, but she could start. She could walk the first ship and find the first 10 problems and fix them and show Surith what to look for and why it mattered. And then Surith could show someone else. And then that person could show someone else. And the gap between what the system tracked and what actually needed attention would narrow. Not because the system changed, but because the people inside it started paying attention to the things the system did not ask them to pay attention to. That was how you changed a fleet, not with a title, not with a directive. With a torch and a pair of hands and the willingness to crawl into the spaces nobody else wanted to crawl into, day after day, until the work became visible because the results became undeniable. They made it 2/3 of the way to Base 6 before word caught up with them. It came in fragments, carried through the drydock's corridors by the informal communication network that ran parallel to every formal one, the network of technicians and contractors and maintenance workers who traded information at shift changes and in mess halls and in the crawlways where nobody above Class 6 ever bothered to listen. The story had already changed shape. By the time Kessa and Surith reached the junction between Bays 6 and 7, the version circulating among the lower deck staff had her welding the pylon with her bare hands while the ship was falling. A maintenance worker she vaguely recognized from the recycling system's crew stopped her in the corridor and asked if it was true that the Admiral had offered her command of the engineering corps and she had turned it down to keep welding pipe. "I did not turn down command of anything," Kessa said. "I told her I would rather fix things than manage people who fix things." "There is a difference." The maintenance worker looked at her with the expression of someone who understood that difference intimately, because he had spent his career on the other side of it, fixing things that nobody managed and nobody tracked, in the spaces that nobody with rank ever visited. "Bay 3 recycler has been pulling to the left on its centrifuge cycle," he said. "I filed a report 2 months ago, still in the queue." "What is the pull rate?" 0.4 degrees per rotation. Not enough to trigger the automated alert threshold. Enough to wear the bearing unevenly. I figure the bearing has about 6 weeks before it starts shedding particulate into the recycled water supply. Kessa added it to the list, item 15. They continued toward Bay 6. Surith was keeping pace now, his stride matching hers, his tool bag slung over his shoulder in the same configuration. He had not yet developed the habit of checking junction boxes as he passed them. That would come. It would come the way all useful habits came, not from instruction but from repetition, from the daily practice of putting your hands on the infrastructure and paying attention to what it told you. The coupling in Bay 6 was worse than the one in Bay 11. The leak was larger, the compression ring had deformed enough to be visible, and the downstream regulator was cycling at nearly twice its rated frequency. Kessa could hear it from 10 meters away, a rapid clicking that had no business being in a regulator's operational profile. The sound was the kind of thing that blended into the ambient noise of a working bay if you did not know what you were listening for. Kessa knew. She had heard that sound before, at the fuel depot, in the month before a regulator failure had caused an atmospheric pressure spike in a maintenance bay and put 2 workers in the medical unit with barotrauma. She fixed it. Surith helped, holding the tools she called for and watching her hands with that steady, absorptive attention that told her he was building the muscle memory even before his muscles were involved. Halfway through the repair, he asked a question that surprised her. Mechanic Road, the senior technical advisor, said he wanted to see your welding technique demonstrated in controlled conditions, with instrumentation. Will you do it? Kessa tightened the replacement compression ring and tested the seal with her fingertip. Tight. Even. The micro-vibration of the leak was gone, replaced by the smooth, steady pulse of gas flowing through an intact coupling. Yes, she said. Why? Because the technique needs to exist outside my hands. Right now, if I get hit by a cargo pallet or fall down a service ladder, the technique goes with me. Every welder who taught me something that is not in a manual, they took a risk by keeping it in their heads instead of writing it down. Hal Rennick taught me to feel the grain through a mounting plate. He taught 3 other people before me. 2 of them left the trade. One of them died in a yard accident on the outer circuit. If Hal had not taught me, that knowledge would be gone. The technique is not mine. It belongs to everyone who might need it. Surith absorbed this. His green eyes had a quality of depth that Kessa was beginning to recognize as characteristic of him, a capacity for taking in information and integrating it at a level below conscious thought, the way a sponge absorbs water without deciding which molecules to accept. The Thyarren engineering doctrine does not include experiential knowledge transfer, he said. Our training is codified. Manuals, simulation programs, certification examinations. There is no equivalent of what you describe, learning by placing your hands on the metal and being taught by someone who has done the same. Then that is the gap, Kessa said. And that is what we are going to fill. She packed her tools, checked the time on her badge display. She had been awake for 15.5 hours. Her back was a solid wall of pain from the pylon work. Her headache had settled into a dull, permanent residence behind her temples, and her hands, steady through the mounting plate bracing and the coupling repairs and the patch weld in Bay 14, were beginning to develop the fine tremor that told her she had about 2 hours of useful work left before her body started filing its own repair orders. 2 hours. Enough time for 1 more item on the list, maybe 2 if they were quick, before she would need to sleep and eat and let her muscles rebuild the fibers she had burned through during the most demanding 45 minutes of welding in her life. Bay 7, she said. The relay I fixed 3 weeks ago, I want to recheck it, then we are done for today. They walked. Surith checked a junction box as they passed it, pressing his fingertip against the casing for a full second, feeling for heat and vibration. He did it without being asked. Kessa saw it and said nothing because saying something would have made it a lesson, and it was better than a lesson. It was a habit forming. The relay in Bay 7 was holding, cool to the touch, stable current flow. The bypass she had installed 3 weeks ago was clean and tight, the connection points free of corrosion, the insulation intact. She checked it with her hands and with her torch's diagnostic mode, and both told her the same thing. The repair was good, the system was functioning, and nobody had noticed it had ever been broken. She was about to pack up when the comm panel on the wall chimed. Not her badge. The bay's own panel, mounted beside the access hatch, the kind that only activated for facility-wide broadcasts or direct communications routed to specific locations. Kessa had never received a communication through a bay panel. Bay panels were for engineers and supervisors. Contractors received their messages through badge notifications, if they received messages at all. Mechanic Road, this is Senior Technical Advisor Corinth. Please respond. It was the older engineer who had analyzed her weld profiles, the one who had asked to see the technique demonstrated under controlled conditions. She crossed to the panel and pressed the transmit key. Road here. Mechanic Road, I have completed a preliminary analysis of the weld data from the forward pylon braces. I would like to share my findings with you, if you have a moment. I have a moment. The fusion profile on your third brace, the one across the primary fracture, is unlike anything in our metallurgical database. The bond achieved what we call a graduated lattice integration, where the crystalline structure of the brace plate merges with the crystalline structure of the mounting plate in a continuous gradient rather than an abrupt transition. In our factory welding processes, the transition between two bonded plates is always a distinct boundary, a line where one lattice ends and another begins. In your weld, there is no line. The two lattices blend into each other over a depth of approximately 2 millimeters. I have consulted with the fleet metallurgist. She has never seen this in a field weld. She has never seen it in a factory weld. She has seen it in naturally formed alloy deposits, where two metals fuse under geological pressure over thousands of years. Kessa listened. She had never heard anyone describe what she did in those terms. She had never needed to. The metal either held or it did not. The theory behind it was someone else's department. What that means, Corinth continued, is that the bond between your brace plates and the mounting plate is not a weld in the conventional sense. It is closer to a natural fusion. The two metals have become one metal. The bond will not degrade over time the way a conventional weld degrades, because there is no weld margin to degrade. There is no boundary for stress to concentrate against. There is no differential in lattice structure for corrosion to exploit. In practical terms, those braces are now part of the pylon. That is what a good weld is supposed to be, Kessa said, part of the metal. Yes, but nobody has ever achieved it with a handheld torch under field conditions. The precision required to create a graduated lattice transition is measured in microns. The torch must be held at exactly the right angle, moved at exactly the right speed, with exactly the right heat distribution, for the entire duration of the weld. Any deviation of more than approximately 15 microns in any parameter would produce a conventional abrupt transition instead. Our factory automated systems achieve a graduated lattice in approximately 1 out of every 200 attempts, under ideal conditions, with computer-controlled parameters. You achieved it 4 times consecutively, under active load, in a magnetic field lying on your back. I was not thinking about microns, Kessa said. I was listening to the metal. There was a pause, the kind of pause that happens when someone with a deep understanding of theory encounters someone with a deep understanding of practice, and both of them realize that the gap between their two kinds of knowledge is smaller than either of them thought, and also completely different from what either of them expected. I would like to propose something, Corinth said. With your permission, I want to instrument your next structural weld, full sensor array, thermal imaging, acoustic emission monitoring, crystallographic analysis in real time, not to evaluate your technique, to document it. so that we can begin to understand, in formal terms, what you are doing when you listen to the metal. Why? Because if we can understand it, we can begin to teach it. Not the way you teach it, hand to metal, welder to apprentice. That is your method and it works. But the Thyarren Engineering Corps has 400 engineers across 31 vessels. They cannot all learn at your side. If we can translate what your hands know into a language that our training systems can communicate, we can begin to close the gap between replacement doctrine and repair capability across the entire fleet. Kessa thought about this. She thought about Hal Rennick, who had taught 3 people what he knew, and 2 of them had left the trade. She thought about the technique living in her hands and nowhere else, a single point of failure in a chain of knowledge that went back generations. She thought about what Corinth was offering, not to replace the way she learned, but to add a parallel path, a way for the knowledge to spread faster than one pair of hands could carry it. "All right," she said. "Next time I have a structural weld, you can instrument it. But the instruments do not tell me what to do. They watch what I do. If the sensor data says I should change something and the metal says I should not, I follow the metal." Understood. I would not presume to tell a master how to use her tools. Kessa blinked. In 20 years of contract work across a dozen postings, in facilities run by humans and Thyarren and 3 other species, nobody had ever called her a master of anything. She had been called a contractor, a maintenance worker, a pipe welder, a hull patcher, a Class 8, and once by a particularly dismissive station administrator, the grease woman. She had not been called a master. "I am not a master," she said. "I am a mechanic who has been paying attention for a long time." "In the Thyarren tradition," Corinth said, "the distinction between those 2 things is considered philosophical rather than practical." He signed off. Kessa stood at the bay panel for a moment, looking at the blank screen, processing the conversation. Then she turned back to Surath, who had been standing 3 meters away, listening to every word with the quiet intensity that she was beginning to recognize as his default state. "The instruments will be useful," Surath said, "but they will not capture the important part." "What is the important part?" "The part where you care about the metal. The instruments can measure temperature and vibration and lattice structure. They cannot measure whether the person holding the torch believes that the weld matters. That is the part that makes the difference, and it is the part that cannot be codified." Kessa looked at him for a long moment. He was young. He had been a technician for less than 2 years. But he had just articulated something that had taken her a decade to understand, something that Hal Rennick had tried to tell her 100 times in 100 different ways, and that she had only finally grasped on the floor of a shipyard at 2 in the morning, welding a patch on a tanker hull that nobody was watching, when she realized that the reason the weld was holding was not the torch or the alloy or the technique. It was that she would not let it fail. "You are going to be good at this," she said. "I want to be." "That is the first requirement. The rest is practice." That was the job, the invisible work. The 1,000 small repairs that kept the infrastructure alive, while the polished concourses above stayed polished, and the people who walked them never thought about what held them up. Kessa had been doing that work for 20 years, and she would do it for 20 more if her hands held out, because the alternative was to stop, and stopping meant that the small failures would accumulate, and the accumulation would produce the cascade, and the cascade would produce the catastrophe, and the catastrophe would produce the committee that asked how this could have happened, and nobody on the committee would know the answer because nobody on the committee had ever walked the crawlways. She had walked them, she would keep walking them. And now Surath would walk them too, and after Surath there would be others, and after the others there would be a tradition, the tradition of putting your hands on the metal and listening, the tradition that Hal Rennick had started on a shipyard floor on Earth, and that Kessa had carried across a dozen postings to a Thyarren drydock at the edge of civilized space, where a young technician with luminous green eyes and steady hands was learning to hear what the metal had to say. Kessa dropped her tool bag by her bunk in the contractor quarters and sat on the edge of the mattress. Her body made its report, back locked up, shoulders inflamed, hands trembling, headache persistent, calves cramping from 14 hours on her feet and on her knees and on her back beneath a pylon that had held 47 million metric tons of warship. She pulled off her boots, peeled off her socks, and looked at her hands in the dim light of the quarters. They were the hands of a mechanic, scarred across the knuckles from contact burns and sharp metal edges. Callus thick on the palms and fingertips, the calluses themselves layered over years like geological strata, each layer a record of a different posting, a different alloy, a different set of tools and conditions. The grease under her nails was permanent. The fine lines of old welds, pale scar tissue from torch splash and spatter, traced across the backs of her fingers like a map of everywhere she had worked. She flexed them. The tremor was still there, but fading. They would be steady again by morning. They always were. 20 years of work had built something into those hands that rest restored and time could not erode, a competence that lived in the tendons and the muscle fibers and the nerve endings, in the precise calibration between what her fingers felt and what her brain interpreted, and what her body did in response. Her badge chimed. A message from Surith, Bay 14 coolant junction holding, temperature nominal. He had gone back and checked, without being asked. A second message followed 30 seconds later, junction box in crawlway 7, section D14. Relay contact corroded, cleaned and reseated. Will monitor. He had gone back and fixed the warm junction box they had found on the way to Bay 14, on his own, without instruction, without waiting for her to tell him it was time. He had simply walked back through the crawlway, stopped at the box, opened it and done the work. Kessa stared at the message for a long time. In 20 years of working in the invisible spaces of a dozen stations, she had never received a message like that. She had never had someone follow behind her and pick up the work she had marked for later, not because they were told to, but because they had learned to see it. Hal Rennick had taught her to notice. She had spent 2 decades noticing alone. And now, on the first day, in the first 8 hours, Surith had begun to notice on his own. The tradition was passing forward, not through manuals or certification programs or fleet directives, through the simplest possible mechanism, one person showing another person what mattered and the second person caring enough to act on it. It was the oldest technology in the universe, older than welding, older than metalwork, older than fire. One human teaching another human how to pay attention, except this time it was a human teaching a Thyarren, and the Thyarren was teaching himself the rest. She thought about what the fleet would look like in 5 years if this worked. Not if Corinth's instruments captured her technique, though that would help. Not if Valen's authorization opened every crawlway and service level to inspection, though that would matter. If this worked. If Surith learned to feel the metal and taught 2 more people, and those 2 taught 4 more, and the chain kept growing. In 5 years, the 7th Fleet could have 100 people walking the crawlways, checking the junction boxes, feeling the grain structure of mounting plates with their fingertips, catching the small failures before they became the kind of failures that made flagships fall. Not replacing the automated systems, supplementing them, filling the gap that the automated systems were not designed to cover, the gap between the catastrophic failures the sensors detected and the slow creep that preceded them. It would not be glamorous work. It would never make anyone an admiral. The people who walked the crawlways would never be the people whose names appeared on the fleet's public commendation lists, because the work they did was the work of preventing things from happening, and preventing things from happening was invisible by definition. You could not point to a catastrophe that did not occur and say, "I stopped that." You could only point to a junction box that was still working, a mounting plate that was still holding, a relay that was still passing clean current, and know, quietly, that it was working because someone had cared enough to check. Kessa set the badge on the shelf beside her bunk and closed her eyes. Tomorrow, she would walk the Vathera. She would start at the bow and work aft, running her hands along every structural member she could reach, checking every junction box, every relay, every coupling, every seal. She would find the problems nobody was looking for. She would fix them. And she would teach Surith to find them and fix them, and he would teach someone else, and the chain would grow in the right direction for once, not from failure to catastrophe, but from knowledge to competence to care. Above her, invisible through 8 decks of metal and composite, the flagship of the 7th Fleet floated steady in its magnetic cradle. The 4 braces on the forward mounting plate held firm, fused to the metal in bonds that the diagnostic instrument said should not exist at the strength they existed at, welded by a pair of human hands that had learned their craft on a shipyard floor that no longer existed, carrying forward a tradition that no manual had ever documented and no certification program had ever taught. The drydock hummed. The pipes carried their fluids. The relays passed their current. The junction boxes held their connections. The infrastructure lived quietly, persistently in the spaces between the polished surfaces, maintained by the people who walked those spaces and put their hands on the metal and listened. Somewhere in the crawlways, a junction box was warming. Kessa would find it in the morning. She always did.